Hey everyone, welcome to the second video on accumulation. We're going to go ahead and go through a quick problem right here and talk about a website where you can look at these more generally. So right now we're looking at this problem right here. We want to plot the accumulation curve formed on the interval -2 to 3 closed interval when you do the following. So start at -2, 5 using 5 left subdivisions, or start at -2, 5 using 10 left subdivisions. So we'll go ahead and do the 5 over here, and then we might start the 10. We probably won't do all of it. I'll let you guys finish that up, but we'll go through and go ahead and do the 5. So we'll go ahead and start with that. So first we're going to calculate our delta x. So we got 5 left subdivisions, so our delta x is going to be our endpoint, which was 3, minus our start, -2, and then divided by 5. And this one turns out pretty nice. This top will just be 5 divided by 5, so our delta x then is just going to be 1. So I'm going to start, like they said, at -2, -5, so right down here. And what we want to do is we want to look at what are the values on this curve. So I'm going to maybe label these first. So in -2, we're using left subdivisions. So we got -2, -1, 0, 1, 2, and finally we'll end right there at 3. So that's 1, 2, 3, 4, 5 subdivisions. We're going to use these left-hand points right there. So I'm just going to go ahead and label those. That's at 1. This one right here looks like it's at 2. Right there at 0 looks like that's at 1 again. Here at 1, this is about -1/2. And then at 2, that looks like it's at -1. And we'll go ahead and stop there because that's the last left point that we'll use. So those are the values we're going to use for our slopes as we draw this curve. All right, so I'll go ahead and switch back over to the red. So starting at -2, 5, we're going to go up with this slope of 1 right here. So that should take us right here, slope of 1. So we go up 1 unit over that change in x1. Now we're going to go up 2. So 1 unit over, go up 2 units. So there's my slope of 2. So we're going to go ahead and go up that way, and that should be kind of a straight line. Like that. Not very good. All right. Starting there at 1 again, we're going to go this way. So this is what our curve is looking like so far. Right there, we got -1/2. So we're going to go down half a unit over there, so -1/2. And then the last thing right there at -1, so we'll go down 1 whole unit right there. And then over 1. So last slope is going to be 1. So that is kind of our approximation of that curve. As you can tell on that interval -2 to 3, you're going to get something like that. It's pretty rough. We're only using 5 subdivisions. If you want to make it more accurate, you can use more. So you can use 10 subdivisions on this one. And I'll just go ahead and do a few of these points. So again, this is a height of 1 right there. Right here in the middle, if you're using 10 subdivisions, you're going to be breaking this up into half units. So right here, we'd have to estimate what is that slope right around there. So I'm going to say this is, this would be 1.75, probably about 1.8, 1.9-ish, something like that. Just say that's 1.8 right there. And then at -1, this would again be a height 2. It's right there. So keep going through estimating those. We'll just do kind of these first three right here. So again, starting at -2, -5, I would go up a slope of 1, but you have to be careful here. You're only going over half a unit. So if I go over half a unit, I'm going to go up half a unit. That's my slope of 1 over that half unit interval. All right. The next slope, 1.8. So normally I go up 1.8 and over 1. Again, we're only going over half a unit. I'm only going to go up about 0.9. So this would be about 1 right here, so slightly less than that, and then over that half a unit, so about right there. So that is my slope of 1.8. Slope of 2, again, normally I go up a whole 2 units, so probably here to about here, and then over 1, but since we're only going over half a unit, it's going to go up 1. So I'm going to go up 1 and over a half, so that puts me about right here, just above -3.25, probably about -3. Or actually -2.7, something like that, 6 or 7. And then you can keep going that way. So you can tell the curve is, pretty similar to what this one was doing. You're just going to get a more accurate drawing as you go. And especially if you wanted to, say, compute some of these values out instead of approximating, you might get more accurate. But the idea is just to see what happens as you draw this accumulation curve over time. So that's kind of the idea there. All right, had a little bit of a glitch with the drawing there. So I've kind of redrawn these, and then we want to answer this question. How much y has accumulated over the interval -2 to 3 in each case? So this first one, we can go ahead and do that because we've drawn the whole thing. So this is going to be, we're ending at a height of -2.5 right there. We started at this height of -5. So that was our starting right there. So how much y has accumulated? So this is going to be, we've accumulated a total of 2.5 units. So this would be the total accumulation. And notice this is that Riemann sum. So our left sum, normally we would call this L5, right? Left sum with 5 subdivisions. That is going to be 2.5. You're just doing it in a different way than area. You're looking at how much y has accumulated by using f as the slope and then drawing it out. But it's the same number that you would get if you were drawing rectangles and calculating area. I'll let you guys finish this one out. This may or may not come out to be the same. It may be slightly different than 2.5. You may get exactly 2.5. It just kind of depends on how accurate you are with your estimation and your sketch as you go. So it should be somewhat close to the 2.5, but maybe not exactly on there. As you use more subdivisions, you're likely to get a different answer as you keep going. All right, we'll go ahead and leave that one and go down to this guy. So limits of accumulation functions. So what happens as you take a limit of these accumulation functions? And for this, I have this website that you might want to go to right there. And there's several things that you can do. So one is you can change the function if you want. I'm just going to leave this sine function up here for now. But we have this function right here, sine function. These little green dots are your slope estimation. So right now I'm using the left sum with all of these green dots representing what slope I would use as I draw out this accumulation curve right here. If you want to change the m, you can change to a midpoint sum, right? So these little black x's are my subdivisions, and we're using midpoints in between each of those subdivisions as our slopes. Or I can use a right sum, right? So now we're using all these right points that finally end right there at B, and using those as our slopes in each segment that we draw out. You can use either left, midpoint, or right. You just have to change that M value back and forth. Notice it does change the curve slightly depending on which one you want to use. You can also increase the number of subdivisions. So as you increase it, right, it gets smoother. As you decrease it, it's going to be a lot more jagged. So only using 4 is worse than 10, which is worse than 100. So you can kind of adjust that and see what happens as you take a limit, which is just using more and more of these subdivisions. The other stuff down here, you don't really have to worry about too much. So those are going to be the main things that you're changing on the sliders. The other thing that you can do though is drag on the graph these A and B points. So maybe I don't want to go 0 to 5, maybe just 0 to 2. So you can adjust that. Where am I starting? Where am I stopping? You can even move B to the left of A if you want to try something like that. So you would start here, but then you would travel left as you draw your curve if B is to the left of A. The other thing that you'll notice is this orange line. This X right here represents where you started from, so that's your start height. And then this is the accumulation of Y. So this is really what you're looking at for that Riemann sum, how much Y has accumulated over that period of time. You can also change your start height, so this will always be directly where A is, but you don't necessarily always have to start at the same height. You could start anywhere that you want. For those guys, you can kind of drag that around wherever you like. Other than that, I think that's it. So you have some questions on this worksheet that you need to answer. And there's some directions there to, drag things around, play a little bit with those. But what happens to accumulation as the number of subdivisions gets larger and larger? What happens when you switch between left, right, mid values with 5 and 50 subdivisions? You take the limit as your subdivision goes to infinity. What's the accumulation? What might be another name for our accumulation function? That's a really important one right there. So make sure you think about these questions. There's some answers down at the end. I don't want to give them all away right now. But think about those questions, write them down, check the answers. If you're confused about what the answers are, how they relate, make sure you post that in the discussion boards. And this will do it for this video.